Hello, my name is Dr. Dan Wedding, and this is DrWedding VB10 Do Loops and a Number Guessing Game. Just like many other languages, Visual Basic has two main types of loops. They are the for loop and the do loop. In Visual Basic, there is one type of for loop, and there are four variations of the do loop. All of the loop types are shown below. For loops, sometimes called for next loops, will repeat a piece of code a fixed number of times. For loops are used when you know, or will know, how many times a loop needs to execute. This loop was covered in the previous video. Do loops are used when you're waiting for something to happen and there is no way to know how many times the loop will run or how long you will be waiting. Do loops can be called do loops, do while loops, until loops, and do until loops. I collectively call these do loops. These types of loops will run as long as the comparison is true or as long as the comparison is false, depending on the loop type. Do loops are used when you are unsure of how long some task will take or how many times a loop needs to run to accomplish the goal. There are four types of do loops in Visual Basic. These four types are shown in the table above. There is also a while end while loop that is not covered in this video. The while end while is exactly like the do while loop in the upper left. Because it is redundant, it is not going to be covered in this video. Do loops are different from the for loop in many ways. The do loop does not have a starting condition. It relies on the previous code to initialize any variables. The do loop does not have a fixed step size. It relies on external forces to change the variable. The do loop only has a stopping condition. The stopping condition is like the comparison in an if. It can compare multiple values and combine them with and or. In Visual Basic, there are two types of do loops, the while and the until. The while loops are shown in the first column, and the until loops are shown in the second column. The while loop will continue as long as the condition is true. The until loop will continue as long as the condition is false. Both types of loops are available to the programmer, but they are also redundant because any comparison statement can be rewritten as its opposite. For example, assume you're writing the code for a dryer. The statement, continue running while the clothes are wet, is the same as continue running until the clothes are dry. Personally, I use the while loop more often and rarely use the until loops. But this is just personal preference and is not out of any advantage the while has over an until loop. The while and until loops fall into two categories, the pre-checked loop and the post-checked loop. The first row has the pre-checked loops. The second row has the post-checked loops. Pre-checked loops run 0 to an infinite number of times. Because the program reaches the check first, it has the ability to ignore this loop and never run. A post-check loop will run 1 to an infinite number of times. Because the program has to go through the loop to get to the check at the bottom, it is guaranteed to run a minimum of 1 time. Here is an example to help you understand the difference. Pre-checked. Dad, can I take the day off of school with my friends and go driving the 1961 Ferrari 250 GT California Spider all over town? The result is performing the task at least 0 times. If your dad does not care, you can do it as much as you want. The task is performed 0 to an infinite number of times. Post-checked. Dad, I took the day off school with my friends and drove the 1961 Ferrari 250 GT California Spider all over town. I hope that was all right. The result is performing the task at least one time. If your dad does not care, you can do it as much as you want. The task is performed 1 to an infinite number of times. If you include the for loop from the previous video, the while loop mentioned at the start of this video, and the 4 do loops that were discussed, there are 6 different loops. In reality, you only need to know 3 types of loops very well. The other loops are redundant. Personally, I use the loops that are highlighted above. Because the do loops only have a stopping condition, they do not have a step value to alter the loop conditions. Do loops need to get information from an outside source to update the variables. If the information is not updated inside the loop will run forever and might lock up the program. If you try to get data from a text box inside of a do loop, the program will lock up. To correct this problem, you will need to use an input box to get data inside of a loop. An input box works a lot like a text box, except it will prevent the loop from running until you have a chance to enter a value. An example of how to use an input box is shown below. The try-catch in your program is there to prevent the computer from crashing if an exception is thrown, such as when a character is entered into a number. A good use for a do loop is to make sure that data is in a range, such as a person entering 20 when the desired range is 1 to 5. A try-catch can't help with this type of error because the integer 20 is being loaded into an integer. By combining a try-catch and a do loop, you can eliminate exception errors as well as unwanted data. If you put the do loop inside the try-catch, an exception error, such as reading a letter in for a number, will break out of the do loop. The catch will take over and you won't read in any more information. The outer try-catch is in control of the inner do loop. If you put the try-catch inside the do loop, an exception error, such as reading a letter in for a number, can be corrected by the catch, and the do loop can continue. The outer do loop is in control of the inner try-catch. A do loop nested in a try-catch and a try-catch nested in a do loop will both be demonstrated in this video. Now for some examples. First, I'm going to do some do while and do until examples. Next, I'm going to move on to a program that will let you guess a random number. I've opened up a new project named VB10. I've also started working on a form. First, I'm going to run some examples using different do loops to get an idea of how they work. The first example is what not to do. In this example, a do while loop will be used to read in a value from a text box. This will not work. Let's start with the variable answer that will be used in this program. Next, we're going to generate a try-catch. Inside the try, I'm going to put a do while loop. When I press do, the word loop is automatically generated, but it doesn't put the while or the until because it doesn't know what I want to do. This is going to be a while loop. The while loop is going to be looking for a true statement. The true statement we're going to be looking for is answer not equal to 5? If answer is not equal to 5, this will be a true statement and the loop will execute again. It will continue until the answer is 5. We're looking at a post-checked while loop. Therefore, we somehow have to initialize answer before we get to the comparison at the bottom of the loop. This will be done by reading in a text box. Again, this is not going to work. We're also going to throw an error message in the catch and run this program. Let's run this program and see what happens. The program compiled without an error, but when we try to run it, for example, type in a number 6 and then run the loop, you can see that the button remains pressed and I've lost control of the form. I can't change any numbers. I'm totally locked up. Let's stop the program and make a change. We can't read in from a text box inside of a do while loop. However, we can read from an input box. These input boxes will stop the loop from running and allow us time to enter a value. The input box allows us to type in a string that will act as a prompt for the user. Let's run the program now. Now you can see when I type in the wrong number, the value is stored in answer, but as long as answer is not equal to 5, this while loop is going to continue to run. It'll run 1 time, 3 times, 500 times, as many times as it takes for me to type in the correct value. Eventually, when I do enter the correct value, the loop will stop running. You'll notice that the text at the top of the input box is the name of the project. We can also change this to be our own title. We can do this by simply adding a second text string to the input box. Now when we run the program, you'll see that the input box has a new title on it. Now that we've tried working with the while loop, let's convert this to an until loop. The until loop will have the opposite logic of the while loop. So instead of looking for when answer is not equal to 5, the until will be looking for when answer is equal to 5. The post-checked while loop and the post-checked until loop will work exactly the same. In both examples, the input box is initializing answer before the value is compared at the bottom of the loop. It's also the method for updating answer so the loop doesn't run forever. Let's run the example with the until loop. As with the while loop, when we press the button, the input box appears. It allows us to check multiple values until the correct value is entered. The post-checked while loop and the post-checked until loop are essentially the same, so which one you use is up to you. Now let's start to investigate the pre-checked loops. I'm going to move the until answer equals 5 to the top of the loop. Like before, answer needs to be assigned a starting value. Answer is assigned the value 0 when it's initialized. 0 equals 5 is false, so this loop will run continuously until I enter the correct value. As before, the button brings up the input box, and the input box will continue to run until I press the correct value. Pre-checked loops may never run. For example, if answer was already 5, the input box would never show up because the loop would never run. We can demonstrate this by setting answer equal to 5. When this button is pressed, answer will be assigned the value of 5. 5 is equal to 5 is a true statement. The loop is ignored, and thank you will be written to the output text box. The difference of a pre-checked loop and a post-checked loop is the minimum number of times the loop will run. A pre-checked loop can run a minimum of 0 times. A post-checked loop will run a minimum of 1 time. Again, until loops and while loops are identical except for the logic. So if I were to alter this until loop to be a while loop, I would have to change the logic. I've commented out the answer equals 5 line. Therefore, answer will start out at 0. 0 is not equal to 5 is a true statement, so the loop will run until I enter the number 5. I hope these previous examples help you understand that the until and the while loop are essentially the same thing. Therefore, learning one pre-checked do loop and one post-checked do loop, along with the for loop, will get you very far in Visual Basic. Now that all the examples are done, we can write the number guessing game. First, I'm going to minimize the example subroutine. Next, I'm going to update the form. I've now updated the form. The form has a button to start the game, a text box to output information, and a label at the bottom. The label is there so that I can print out the random number while I'm debugging the program. It would defeat the purpose if I always printed out the number you were supposed to guess. However, when you're debugging a program, you need to know this information. To start the program, we're going to need a random number generator. The random number generator needs to have randomize issued one time at the start of the program. We will do that inside of form load. So double click on the form, bring up form load, and type randomize. If you remember back from the previous video, randomize will mix up the random number file so that you don't always get the same numbers every time you run the program. Now we're going to have to go back to the form and open the button code so we can start to write the game. We're going to need a value for the random number and a value for the guess. Next, a try catch. And inside the try, we're going to generate the random number. This equation will generate a number between 1 and 10 and store it in intrand. Now we're going to write a post-checked do while loop. It's going to be post-checked because we want this loop to run a minimum of one time. And every time we run the loop, we're going to read in a value from an input box. Inside the while loop is where we're going to read in the value for the guess. We're going to use an input box for this. The loop will compare intrand to int guess. If they're equal, the loop will stop, and if they're not equal, the loop will repeat. So the command will be loop while intrand is not equal to int guess. This is the basics of the program, but we're going to need to go a little further. First of all, I'm going to print the intrand value to the label on the screen for debugging purposes. Once I complete the program and I know it's running correctly, I can remove this. I'm also going to update the text box on the form. This will keep track of the previous guesses. Let's test the program and see how it's running so far. When we start the game, the random number will show up at the bottom of the form. This is only for debugging purposes, and once the program's running, this will be removed. The input box is now up on the screen, and we can enter a guess. Let's assume we guess 6. The text box is showing us that we guessed 6, so we don't guess the same number twice. We continue to guess until we finally hit the right answer. Once we guess the correct answer, we'll have to put some information up on the text box to let the player know the game is over. The added text will go underneath the do while loop. I'm also going to add a counter. This will be used to keep track of how many guesses the player took. I'll need to add a variable called int count. And when the game starts, int count will have to be set to 0. If you think I don't need to set int count to 0, you're right, I don't. Int count is a local variable. Every time the subroutine runs, it's reinitialized and set back to 0. I'm setting it to 0 to form a good habit. In a large program, you're going to have both local and global variables. Although the local variables are going to be reset every time the subroutine runs, the global variables are not going to be reset. So if later on you change this local variable to a global variable, you won't have to run around your program and set them to 0. Next, every time the person guesses, we'll increment their counter by 1. And we'll add this information to the text box. The extra space is so that my count number and my guess number are not smashed up next to each other. Let's run this version of the program. We already know the random number is 4, so we're not going to guess that because we want to test the program. Now we're keeping track of the number of guesses and the list of numbers that were guessed. Let's run this program a second time, but this time we're going to enter an invalid character. What happened was the try-catch took over and ended the subroutine. There was no indication that an error occurred, so we're going to have to add some kind of text to the catch so that we know it was tripped. We know the random number is 9, but we're going to enter a letter instead. We get an input error and the program ends. Let's start the program again. We have a new random number, however the text box still has the old error message on it. The new information is being combined with the old information. So when the subroutine starts, the text box will need to be cleared. The last change I want to make is that when the program has an invalid input, I want the game to continue. I don't want the subroutine to stop. I want the person to be prompted for a new input. That means I'm going to have to put the try-catch around the input box only. The try-catch is now only around the input box. This will prevent the game from stopping if an invalid value is entered. We don't want to count the invalid input as a guess, so we need to subtract 1 from int count to undo the one we added at the start of the do loop. I am also going to overwrite int guess. I'm going to overwrite it with -1 because -1 is a valid integer, and at the same time, it is not in the range of values that could be in the guessing game. If there was an invalid entry and the catch was tripped, we don't want to print the -1 as a guess on the screen. So I'm going to put an if statement around the append text under the try catch. Now I'm going to add one last do while loop. It's going to go around the input box. There's nothing there preventing the user from typing in any number they want, including the -1 error code. By adding this pre-checked do while loop, I can have one standard prompt. However, if the user enters an invalid value, the prompt can change, letting them know they need to enter a value between 1 and 10. This will also prevent the program from continuing with a bad value. Let's test this program. We'll start the game, and we know 8 is the number we're supposed to guess. Let's start off with entering a character. Again, we get the input error, and the loop starts over. Next, we're going to try entering a number that's outside the range. The prompt changes to invalid entry, try again. This will continue until I enter a valid value. 5 is a valid value, so it showed up as a guess on the text box. However, it's not the value that's going to end the game. Let's try another error to see if the guess count increases. And the count is correct. Now I'm going to comment the code. Let's walk through this code. When the button is pressed, int guess, int rand, and int count are all set to 0 when they're declared. Int rand is then assigned a value between 1 and 10. Let's assume this is 7. The 7 is written to the corner of the screen for debugging purposes. Int count is set equal to 0. The text box is also cleared. Next, we enter the do while. This do while will run until the person enters the number 7. We increment int count by 1. We then enter the try catch. The try catch is there to prevent errors if the person enters a letter instead of a number. Next, the input box comes up on the screen, and the person enters a number. Let's assume this number is 4. If it's 4, the do while directly below it is skipped, because 4 is less than 0 is false, and 4 is greater than 10 is false. Because they're both false, this loop is skipped. The catch is also skipped because 4 was a valid integer. We then go to the if statement under the try catch. 4 is not equal to -1 is a true statement. Therefore, we will output to the text box the guess number, 1, and the guess, 4. Then we go to the loop while command. 7 is not equal to 4. Therefore, the do while loop starts over. Int count now goes up to 2. This time, when we get to the input box, let's assume the person typed in 55. 55 is greater than 10. Therefore, the do while loop inside the try will start running until the person enters a number between 1 and 10. So in this inner loop, assume the person types in 5. Again, the catch is ignored. 5 is not equal to -1. And the word guess, the number 2, and their guess of 5 will all be printed to the text box. 7 is not equal to 5, so the loop will repeat again. Now we're up to int count 3. This time, the person types in the letter W. The try fails and the catch takes over. The text box will receive an input error. And because this third guess is invalid, we'll decrement int count by 1. An error code will be inserted into int guess of -1. The catch ends and the if statement takes over. The error code -1 is not equal to -1 is false. Therefore, nothing will be printed to the text box. The loop will start over because 7 is not equal to -1. Now int count is incremented again, and now it's 3. This time, the person actually guesses the correct number, 7. 7 is not less than 0, and 7 is not greater than 10. Therefore, the do while below the input box is skipped. Catch is also skipped. 7 is not equal to -1, so the information is updated on the text box as before. And 7 is not equal to 7 is a false statement. Therefore, the do while loop does not run, and it falls down to the next line where it prints correct to the text box. I hope stepping through this slowly gave you a good explanation of what every piece was doing in this code. In review, in Visual Basic there are two types of do loops, the while and the until. The while loops are shown in the first column, and the until loops are shown in the second column. The while loop will continue to run as long as the condition is true. The until loop will continue to run as long as the condition is false. The do loops fall into two categories, the pre-checked loop and the post-checked loop. The first row has the pre-checked loops. The second row has the post-checked loops. Because the rows are redundant, you only need to use one from the first row and one from the second row. Do loops are used when you do not know how many times a loop will run. The for loops that were previously discussed had three main parts: the starting condition, the stopping condition, and the step size. The do loops only have a stopping condition. The do loops do not have a starting condition. They rely on the previous code to initialize any variables. Do loops only have a stopping condition, and the stopping condition is the same as an if statement comparison. The do loop comparison can use greater than or equal to, less than or equal to, and not equal to. Multiple comparisons can be combined with not, and or. Do loops rely on an external input to change the conditions in the comparison. Because the stopping condition on a pre-checked loop is checked before the loop starts, a pre-checked loop will run a minimum of 0 times up to an infinite number of times. Because the stopping condition on the post-checked loop is checked at the end of the loop, a post-checked loop will run a minimum of 1 time up to an infinite number of times. There are 6 loops shown on this page, but it is important to completely understand 3 of them. You must understand the for loop, one of the pre-checked do loops, and one of the post-checked do loops. Which loops you choose is up to you. In order to read values inside of a loop, you will need to use an input box. The input box will pause the loop so you have time to enter the information. An example of how to use an input box is shown below. Combining a do loop and a try catch can help you filter unwanted data and prevent the computer from crashing. An example of a do loop inside of a try catch and a try catch inside of a do loop are shown below. If you find these videos useful, please like and subscribe. It is the only way I can continue to make these videos.